Hello aviators, how are you today? My name is Magnar Nordal and I am a retired airline captain. When a senior aviation executive publishes a post about aircraft performance, you would expect the information to be accurate. Unfortunately, several of the speed claims in this particular post are misleading or simply impossible. At 36,000 feet, the speed of sound is approximately 1,062 km per hour. So how can the post claim that conventional passenger aircraft fly faster than that? Let me explain. Airliner speeds are described in several different ways, and they should not be confused. Normal cruise speed is the economical speed normally used in service. At lower altitudes, the aircraft is limited by VMO, the maximum operating indicated airspeed. On many airliners, VMO is between 330 and 350 knots and is marked by the red and white barber pole on the airspeed indicator. At approximately 28,000 to 30,000 feet, depending on aircraft type and atmospheric conditions, the aircraft reaches its crossover altitude. Above this point, speed is normally expressed as a Mach number rather than in knots. A Mach number is the airspeed expressed as a fraction of the speed of sound. For example, when the airspeed is 85% of the speed of sound, the Mach number is 0.85. The relevant limit then becomes MMO, the maximum operating Mach number. At low altitudes, VMO usually becomes limiting because dynamic pressure and structural loads increase with speed. At higher altitudes, MMO becomes limiting because compressibility effects, shock waves, and changes in handling become increasingly important. There are also higher certification speeds, such as the design dive speed and design dive Mach number. These are used during flight testing. They are not normal operating speeds and should not be compared directly with cruise speeds. For this comparison, I will therefore use MMO as the primary measure, with normal cruise Mach as the secondary indicator. The speed of sound depends mainly on the air temperature. At sea level under standard atmospheric conditions, where the temperature is plus 15 degrees Celsius, the speed of sound is 1,225 km per hour. In the international standard atmosphere, temperature decreases by 1.98 degrees Celsius per 1,000 feet until it reaches minus 56.5 degrees Celsius at approximately 36,000 feet. At that temperature, the speed of sound is 1,062 km per hour. The temperature then remains constant up to approximately 65,600 feet. So the speed of sound also remains constant throughout that layer. This means that the true airspeed of 1,249 km per hour at normal airliner cruise altitude corresponds to Mach 1.18. A conventional subsonic airliner simply cannot fly that fast. Only two supersonic airliners ever entered service, Concorde and the Tupolev Tu-144. The Tu-144 first flew a few months before Concorde and was designed for speeds of around Mach 2.2. However, its development was plagued by technical problems, leading to several major redesigns. The aircraft suffered from poor reliability, excessive cabin noise, and an extremely short commercial career, completing only 55 scheduled passenger flights. What it did have was speed. Sources differ, but the Tu-144 reportedly reached Mach 2.35 or 2.40 during flight testing. The post claims 2,575 km per hour, equivalent to about Mach 2.42, so the figure appears slightly exaggerated. Its normal operational cruise speed was much lower, generally between Mach 2.0 and Mach 2.1, while maximum operational cruise is commonly quoted as Mach 2.15 to 2.20. The Concorde was also designed for speeds up to Mach 2.2. However, sustained flight at that speed would have caused excessive aerodynamic heating, particularly around the nose and leading edges. However, sustained flight at that speed will have caused excessive aerodynamic heating, particularly around the nose and wing leading edges. Its airframe was constructed mainly from a heat-resistant aluminum-copper alloy, and the maximum permitted skin temperature was approximately 127 degrees Celsius. This limited normal cruise to Mach 2.02 and maximum operational cruise to Mach 2.04. The post gives Concorde a speed of 2,180 km per hour. That corresponds closely to Mach 2.04. This is the only speed claim in the post that appears accurate. Concorde reportedly reached Mach 2.23 during flight testing, but that was not an operational cruise speed. Unlike its Soviet rival, Concorde enjoyed a successful 27-year career, carrying around 2.5 million passengers on nearly 50,000 flights. It made it possible to leave London or Paris in the morning, have lunch in New York, and return home the same evening. Comparing Concorde's operational cruise speed with Tu-144's maximum test speed is therefore misleading. One figure describes a speed used in service, the other describes a flight test. Modern airliners use supercritical wings designed to reduce wave drag at high subsonic speeds. These wings have a relatively flat upper surface and curved underside. This shape delays and weakens the shock waves that form over the wing. This may appear counterintuitive because lift is often incorrectly explained as being produced simply by a more curved upper surface. In reality, lift is produced by the pressure distribution around the wing and the resulting downward deflection of the airflow. For a more detailed explanation about lift, check out this video. The supercritical wing is optimized for efficient cruise. During takeoff and landing, trailing edge flaps and leading edge slats increase wing camber and wing area. This increases the lift coefficient and allows the aircraft to fly safely at much lower speeds. The post claims that the Boeing 787 Dreamliner can fly at 776 miles per hour, or 1,249 km per hour. At minus 56.5 degrees Celsius, that would correspond to Mach 1.18. The Dreamliner is not capable of supersonic flight. The Boeing 787 normally cruises at Mach 0.85, equivalent to about 903 km per hour under normal cruise conditions. Depending on the variant, its MMO is Mach 0.89 or 0.90. Flying significantly faster will cause wave drag and fuel consumption to increase sharply, while saving relatively little time. The quoted speed of 1,249 km per hour is therefore not a credible normal operating speed for the Boeing 787. The same applies to similar claims about the Boeing 777 and Airbus A380. Modern airliners show remarkably little variation in cruise speed. Most long-range wide-body aircraft cruise at approximately Mach 0.85. Modern narrow-body airliners typically cruise at Mach 0.78, equivalent to 829 km per hour. Narrow-body aircraft usually operate shorter routes, where flying faster would save only a few minutes while increasing fuel consumption. Long-range aircraft spend many hours in cruise, so a higher speed provides a greater operational benefit. Older jetliners show more variation. During the 1960s and 1970s, fuel was relatively inexpensive and speed was an important selling point. Among the wide-body aircraft in the comparison, the Boeing 747 SP had one of the highest normal cruise speeds. The classic Boeing 747 family also had the highest maximum operating Mach number among the subsonic airliners considered, at Mach 0.92. Among earlier narrow-body and first-generation jetliners, the Boeing 707 and Boeing 727 had MMO at Mach 0.90. The Vickers VC-10 normally cruised faster, but its maximum operating Mach number was slightly lower. At the opposite end of the ranking is the British Airspace 146, later developed into the Avro RJ. It was slow by jet airliner standards, but speed was never its purpose. It was designed for quiet operation, steep approaches, and excellent short-field performance. I have seen it operate from runways as short as 900 meters, which are unsuitable for conventional jet airliners. So, which airliner is the fastest? The answer depends on what kind of speed is being compared. The Tu-144 appears to have achieved the highest speed during flight testing. Among subsonic airliners, the Boeing 747 SP was one of the fastest routine cruisers, while the classic Boeing 747 family had one of the highest maximum operating Mach numbers. What this comparison really demonstrates is that modern airliners are not designed to set speed records. Advances in aerodynamics, engines, and materials have been used mainly to reduce fuel consumption, increase range, lower noise, and improve safety. A normal cruise speed, an operational limit, a design dive speed, and a maximum test speed are not interchangeable. Comparing them without context produces misleading conclusions. That is the main problem with the original post. I claim that the Boeing 787 flies at 1249 km per hour would make it supersonic. It does not. The Dreamliner normally cruises at about Mach 0.85. The same does the Airbus A380. The lesson is simple. Aviation figures need context. Before declaring an aircraft the fastest, first ask what kind of speed is being quoted and whether the figure is physically and operationally credible. And most of all, do not trust AI. Always verify. This is all for this time. As always, a big thank you goes to the members of this channel. They make this content possible. Thank you for watching, have a wonderful day, and happy landing!